Going to start our science lesson for today with a review. Who can name the 4 kinds of energy? Brooklyn.
Light energy, heat energy, electrical energy, and mechanical.
That is correct. That's all 4 of them, okay? If I have a flashlight like I have today, what kind of energy am I using with my flashlight? Lainey?
Light energy.
It is light energy. And what?
Heat energy.
We do have some heat, okay? If I touch it and feel it, my hand starts to warm up. So there is some heat energy there. Brian?
Electrical energy.
Electrical energy. Where's the power coming from to make that electrical energy? Andrew?
Battery.
We have a battery in there, okay? Probably we have, how many batteries do you think?
2.
Most flashlights take 2, some 3, right? Miss Malloy is going to show us the inside of a battery. Let me just click on that. And the inside of the battery, we can see that we have a carbon rod, and that carbon rod's connected to the bottom and top of the battery, and the top would be the positive end, Miss Moy marked it, and the bottom is the negative end. We also have a metal part called a zinc container. Zinc is a metal, and a chemical paste inside it. And the paste is actually going to create what we call electrons, which help flow from the negative to positive end of the battery and make the energy to make the battery work, to make other things work when we use batteries. The chemical paste then is really chemical energy. So we have chemical energy turning into electrical energy, turning into light energy, and giving off heat energy. All our energy is working in just something as simple as a flashlight. Batteries we had a long time ago in flashlights were very weak batteries. And the bulbs were very weak also. And when they were weak, they'd only give like a little quick burst of light when you used them. Very quick. So people would say actually that it gave just a flash-a-light. Flash is another good synonym for quick. Well, it's good for quick. And yeah, you can see that they took that flash-a-light that they were seeing and created a word for a new product like this, and they called it a flashlight. Here's a picture, I think I have one, of a really old flashlight. Somehow that went over here, okay? This one is a flashlight. It had a switch to it. What do you notice different between that flashlight and the one that I have? What do you notice something, Remy?
The bulb's different.
The bulb is different. Look at the bulb for this one. And why do you think we would do that? That we make the bulb maybe more recessed? It didn't look like it was. It's kind of poking out. Why do they do that? Why?
You won't burn yourself?
Well, it does give off some heat energy, but do you think there's enough heat energy to burn you? Not really. They do get a little warm though. Julia?
So, it produces more light because you said that it only does like a flash of light. So if it was more in, then it wouldn't give like as much.
It actually does, but not just because it's not a flash. The good, better batteries make it not have a flashlight, but this is actually, and there's some metal, and the metal will reflect the light and make it brighter. And they found that out as they kept trying to experiment and make better flashlights, I guess. Caitlin?
The materials different.
Yeah, okay. Back then, did they have plastic?
No.
They didn't have plastic way back then. This is like in 1896, okay? Long time ago. They didn't have plastic, so they made it out of some kind of, what do you think? Metal. There are metal parts on it. And actually the tube is probably some kind of leather. Yes.
There was a cap that goes onto the back of the flashlight.
Yeah, and it had a word on it. It's actually, you probably can't read it, but it says matchless, okay? Matchless because
You don't use matches to use it.
you know, and matches to use it. Good idea, okay? Everything else they had to use a match, and you had to light a candle to see light. But with this kind of flashlight, we didn't have to. really interesting to see them. And here's another one. Oh, let's see if the machine will go. Okay. Here's another one they made called the electric candle. They made that one even look like a candle, but more like a
Flashlight.
oh, kind of like a flashlight,
Candle.
like a lantern. A lantern. They could hold it. Okay. Yes.
I have a question. Like,
Sure.
were these more expensive in the old days?
Well, what do you think? You think?
No,
Well, when something first is made and it first comes out,
It's not.
it's usually pretty expensive when you first get it, okay? And then as they get more and more of them made and it becomes more common to find it, then prices usually go down because now everybody has it. Miss Malloy remembers when computers first came out, they were very expensive, and they're still expensive, but maybe not as much as they used to be. Yes.
Usually back then, $1 was a lot.
Well, that's true. There's something called inflation, right? That's a whole nother subject. Okay, when you begin to make a path for electricity to work, it's called a circuit. What word does circuit look like? What word does circuit look like to you, Joby?
Circle?
It does look like circle. Okay, let's see if we can write that up here. Oh, my pen's not working there. Okay, that's okay, I can get it. Okay? It looks like a circle. Oops. Okay? Got a little mess there. Circle. Any other word? What else? Down?
Circus?
It does look like circus. Okay? It does. It does look like circus. Okay? You can see circle, circus, circuit. They all have to do with something round. Even circuses, because have you ever heard of a three-ring circus? Well, actually, you sit in a round circle usually to see the circus, not just straight on, but many times you're sitting around. Okay, so it is like that. Yes.
And the circus is like a circle too.
It is good. That's a good observation. This word circus comes from a Latin word called circuitous. And when things are circuitous, that meant to go around. So it went around. Today's objective for us to do, did you have something to add, Marco? I'm sorry.
Yeah, in circuitous, you can also see the word circuit.
You can't. Okay, it's like right there, isn't it? Okay? Back on my pen. Yeah, it worked that time. Okay? Circuit. So that was a perfect word to use to describe the path that electricity is going to take. You want to keep that in mind about circle and the path that it has to take. You're going to use a battery, a bulb, and some aluminum foil to create a circuit or a path for electricity. Well, I'm thinking about that, okay? When you're going to know you're successful at this lesson and can assess yourself, because if you're successful, you're going to be able to light the bulb. When you're not lighting the bulb, then you're not successful yet. So you can assess yourself. We're going to get in groups, and Miss Malloy wants you, though, before we get in groups, to fix your science notebooks. You need to make sure in your science notebook, thank you for opening them, you're going to make sure that you draw your paper, a line across your paper like this. At the top you can write ways the bulb did not work, and on the bottom you're going to show ways the bulb did work. So as you work today, you want to make sure that you put down, on the page, you want to make sure that you put down anything that happens. You're recording everything. Even when you try a way and it doesn't work, and oh, that doesn't work, and I know you're going to want to quickly go on and try something else, you need to stop and draw a little picture of what did not happen. It's kind of important, scientists, when they work, to show what works and what doesn't. They record everything. So while you're fixing your notebooks, I'm going to get you in groups. You're going to work in pairs. You're going to, we'll let the computer hook us up with a partner. the first name in the partner list is going to get the materials. And when you get your materials, please make sure that you have inside your container a battery, a bulb, and a piece of foil. If something's missing, let me know. Bulbs or glass, they'll break. If you have a problem, let me know, we can fix it. I believe we need to hook Julia up with Ella because Xander's absent. And I think that's the only one we have to change, right? Right?
Yeah.
Okay. All right. I'm going to see you trying to make a circuit on the path that you go. It's a good idea. You have an idea what to do?
Yeah.
Okay. Oh, you tore your foil? That's a good idea. Wow. Share it?
I guess it was an accident purpose.
Okay.
Well, not
Keep going.
purpose, I mean.
All right. Keep trying. I like that you're recording what you're doing. I see that going on. That's a good thing. I see some ways it's not working, and I see that going on your paper. Thank you. It won't work? Let's see what's happening.
Yeah. So what? No.
The battery don't go hot. Right? She's still trying over here.
Well, it's that around.
It's getting hot. If it's getting hot, you know that something is working though because it is hot. Right? Okay.
It's not working.
Right.
Well, okay. This one.
Not yet. Okay.
We found out if you rub your eraser on it, it might like sting. Let me get my pencil.
The ball was stinging you?
Well, it isn't that hot.
Okay.
Okay.
Okay, but remember you need to try to make your circuit, okay? Try to make a circle. Remember that we need to try to make a circuit, and a circuit's going to have to be a path. Remember your battery and the positive and negative end? We need to try to figure out a way to make that electricity flow through that entire battery, don't we? Okay?
Yes. Try a different way.
Well, I like that. Try a different way.
I got it like this.
Almost. Okay? Not, no. Okay?
Now let me try it. Nope. Wait, you like this? I think
Okay. Good. I see somebody over there really trying.
Actually,
Okay.
it's
Good.
working.
Okay. Oh, excuse me. Okay.
Well, I'm sure you have enough. And I'm also running out of place to write it.
That's okay. Can you another sheet here?
Yeah. Positive side.
Okay, but you are making a path, and you're doing a good job over here, because I think you're on the right track. Keep going with that, Laney, and you might get it.
I got one thing to say.
You're shocked, but then you know something's working if you got shocked. Okay, so you're on the right path. I am going on with that.
Piece on the bottom.
Okay, you're okay?
Doesn't it?
All right.
I thought it used it. Oh, because it's not on.
Okay, I think you're gonna get it, okay? I think you're almost there, okay?
I got it.
You got it? Oh, somebody got it.
We got it too. We got it too. Okay, I see it. I got
Let me know. So they've got theirs turned around the other way, okay?
It works!
Make sure you draw. Make sure you draw the way it's working also. Okay. Alright. Okay. Alright, baby. Alright. This one's gonna speak that. Here's the new light bulb. Okay. Okay, well let me get this swept up, okay? Because the bulb's right. I'm glad we see it working. What can we do to make the bulb brighter? What can we do if we want to make the bulb brighter, Margot? Just a minute, honey. Okay, we could. Okay, this group put two batteries together, and they're seeing that it is brighter. Okay, if you want another battery, you could get one and see if you can make it brighter. I don't want you to put any more than two bulbs together, batteries together, because it might, okay, oh that sounds good, okay? But I don't want you to put, listen one more time, stop for a minute, 3, 2, 1, last word, listen. Okay, I don't want you to put more than two batteries, because if you put more, it could hurt the bulb. Now, Proma is making an observation because she went with another group and put a battery together. So now they got two batteries and they got two bulbs. And she says, both bulbs, and what are you saying? She connected
We got it to stay steady.
And it also makes it brighter. Yeah. And if we put two batteries, it's even brighter with two bulbs. Yeah.
Okay, that was pretty good. So they were pretty creative over here. They were able to do that because they shared the bulbs, okay?
Ours, we got it to stay steady while you can still see the rays of light.
You can, okay?
And feel it. It's a bit
You can, okay? It's very good observation, Marco. Alright? You got it to go brighter? Looks good. Alright? Alright, I think most people have seen that. You got that to go brighter?
This is the one that got brighter. It's getting very brighter.
Okay, that was good.
We got on the negative side. Both of them. Both of them on negative. Both batteries on negative.
Okay, that worked really well.
We got it.
So it worked on either end. That was a good observation too.
We got it.
Negative and positive.
Okay. All right. We're going to ask you to put materials back in containers. Put containers back on the table. And get ready to come to Science Circle so we can talk about what happened. Okay? Okay. Let's think about the investigation we did first. What did we have to do to make the bulb light? What did we have to do, Rami?
We had to put the foil under the battery.
Okay.
And then we put the other side under the battery on the negative side. We put the light bulb on in the stem, and then we put the foil. by the
Okay.
battery.
And what did you have to make sure that the foil was touching for the light to go on? It had to be touching a certain
Yeah.
spot, right? What did it have to touch, Dylan?
You had to touch the metal or around the bulb.
Okay, the metal part. If it touched the glass, would it work?
No.
Why not?
Because
Because it's metal at that
conductor
part.
of electricity.
Oh, I like that. Toby, say that again.
Glass is a conductor of electricity.
Yeah, okay. I'm so proud you used the word conductor. What did you mean by that? Let's just maybe make sure we understand that again.
It's
Layla?
conductor means like it's a material that lets heat go through the object.
Okay, it lets it go through the electricity, or we saw even in magnets that they would conduct the magnet in a way and make it work. Yes.
I found that when you did it with a tube bulb, it wasn't only brighter, it was more hot. And I could put my fingers around it and I could feel and see the rays of light.
That's a very good observation.
I like to add on to what Marco said. So like when you put the bulb on and it was lighting, your fingers, if you were touching the aluminum foil, then your finger could have like got really hot and could have hurt.
Okay, and I like the way you used your conversation clue with that. Thank you. Okay, Roma?
Andrew and Yuan and her other person, we actually put two batteries together on the negative side and the two bulbs on the negative metal part, and then on the aluminum, we put the aluminum foil in between both of them, but they were still touching the metal, and then they both lit, and mine is kind of like Margot's. Like I could feel how hot it was, and it was definitely brighter.
You have to make a circuit with a circle, like put it on the bottom and make it.
And I'm so glad you brought us back again about circuit, okay? Because that's what's really going to make it work, right?
Circle, you gotta
Yeah.
put in.
You got to make the circle. You got to connect the bottom to the top and get
It
that.
has to be complete.
Yes, okay? And that's going to be what we call a closed circuit when it's going to work. If we take something out of that, we had torn the aluminum foil, then it's an open circuit and it's not going to work. Okay? Yes.
Well, something that me and Julian found out was that the light bulb would have to be on the little knob of the carbon rod in order for it to work.
Okay.
And when we just put the aluminum foil on the carbon rod, it didn't light the bulb, but it gave me a shock.
Okay. All right. And we already said when we used two batteries, it just got brighter. And why was that? Because what were we doing? Why did that get brighter, Julia?
More energy?
We have more energy, okay? If we continue to increase that energy, do you think we could light a bulb like this?
Yes.
It would take a lot though.
We could, but it would increase.
But it would take a lot.
It would take a lot, like a whole lot, or just hundreds, she said. Okay? Take a lot of batteries. Okay? Well, even if we just use two just to kind of prove it, okay?
I would say probably 6.
You think two would light it?
No.
3.
No. 550.
Does it work like that? 550? Actually, so this is the kind we use in our house. So what kind of energy do we need to really light this? We need it to come from where? Zoe?
Electrical energy?
Right, so it's going to come from
Wires and
electricity, from our wires and all, okay? Do you think we use a lot of electricity
Yes.
in our life? Think about it. Do you?
Yes.
Talk. Why?
Like you do it to turn on your light and turn off your light when you're going to bed or something.
Okay. Yes.
You use your light when you wake up, and just go to school and stuff, leave your house, you turn it off, whatever.
whatever you do with the light.
When you put a plug in the outlet to charge something.
Okay, that's when we're using it, okay? Yes, Paloma.
When it's stormy outside, it gets dark, so you need to put on the lights.
Okay. Remember, in conversation circle, we don't have to just wait for our hand. We can just talk, right? Okay.
Like on the streets, there's lights at night so you don't crash.
Okay. So what would our world be like if we didn't have electricity? What would your morning be like without it? Start off and thinking about that, Remy.
It would be really dark.
Okay.
Like it would be dim.
Well, we wouldn't have any light?
Well, we would have
the sun.
But inside your house at the night, it would be really dark. So you would have to use like more candles and stuff, matches, and if we didn't have electricity.
Alex?
If there was no power at the early in the morning, if there was no light, it would be really dark and you couldn't see, and so you might and you could kill yourself.
Yeah, you could slip on something.
Fall upstairs.
Fine, and fine. Me? Okay.
You even have
Walk on the
stairs.
streets and the car crashes onto you.
Right, because on the street there wouldn't be any street lights, would they? I didn't think of that. Or any stop lights.
If you had no power, you could
Okay, let's be polite. Let's be polite to each other. And here, I like the ideas you have, okay? Zoe, you listening? Thank you. Margot?
I'd like to add on to what Ella said. Actually, it'd be pretty impossible to get into a car crash because there wouldn't be any cars.
Yeah.
And why not?
Because you need electricity to power cars.
Some cars.
Well,
Most cars run on solar power. Cars.
some do. But the cars are running on gasoline. So the gasoline, and that's the big thing about how that works, but it really is the gas that's making it go, not really the electricity. But
The light.
when I go to the gas pump to get the electricity, to get the gas, to get the gas, that runs on electricity. So once I want to fill my car up with gasoline again, I wouldn't really be able to do it without electricity. Okay? Because I wouldn't be able to get it out the pump. The pump's on electricity, but the car's not. The car's on gasoline. Okay? But there are some electric cars. Okay?
My dad
Yes.
has one.
Really? Okay, cool.
And if there wasn't any electricity, you couldn't really power any of the machines that we have that get the gas, which means that cars wouldn't ever really even be created because you couldn't really get the gas. And if they were created, they'd be probably extremely expensive.
So if we know that we use a lot of electricity, and if we know that we need it or we're going to run out and not be able to do some of the things and play with our games and things that we like to play with, how can we save electricity? What can we do to save it, Zoe?
Not use it much.
But how? Tell me a way to not use it.
Well, like you could go and do a board, use it. Well, you could.
Okay.
You could light a candle. And
Well,
that is.
How would you get the
Yes, we
match
could.
if it's so dark?
we better get it before the sun goes down, huh?
For a second. I know when you can.
Okay. Toby.
Listen, cool, watch less TV.
We can watch less TV.
Play
he said.
less video
Hmm.
games.
Okay. Okay. Caitlin?
When you leave the house, you can turn all the lights off.
Ah, okay.
Saving so
I hope you listen to Caitlin. What did she say?
When you leave the house, you can turn off the lights.
Yeah, okay. That's something we can do. We don't have to cut out the fun things that we do, can we? All right? We'll call it. The writing assignment you have, put your hand down for a minute. The writing assignment you have when you go back to your place will be to think about how the world would be changed if we didn't have electricity. Okay? So we're going to think about that. Write a good paragraph. Okay?